This video is part of CAE Associates Ansys e-learning series. CAE Associates is an engineering consulting firm in Middlebury, Connecticut, specializing in finite element analysis and computational fluid dynamics. We have been an Ansys channel partner since 1985 and have developed our Ansys e-learning series to help you maximize your software investment. Please visit our website, which includes an extensive resource library with over 250 items and counting in an easily searchable area. We also invite you to visit our Engineering Advantage blog, where we share insights from our many years of performing engineering analysis. CAE Associates also offers an extensive schedule of Ansys courses taught at our Middlebury office. If you need help deciding on the best courses to take for your application, visit our CAE University page. The complete library of e-learning recordings is available for viewing in our resource library and also on our YouTube channel at youtube.com/CAEAI.
Great, thank you, Christina. Give me a second to get my screen activated. Okay. I want to take literally just 2 minutes to run through a couple of slides with you. No more than that, just to set the stage for what I'm going to talk about today and what I want to show you. This is Ansys Space Claim Direct Modeler, or SCDM for short. Well, the background on this, Ansys partnered with Space Claim to come up with this unprecedented next-generation 3D tool for manipulating geometry in a way that's no one else has really done before. So we've partnered with, Space Claim and Ansys have partnered for about 4 years or so, and this really fills the gap between the pre-processing technology and all the simulation that people need to do. So Space Claim does power ASCDM. The background on Space Claim is that we were founded by the founders of PTC and SolidWorks, so there's a rich history of a knowledge base of knowing geometry and how to manipulate things and get from point A to point B very quickly. Ease of use and speed is what this software is all about, and you'll see that as I go through it. Now, in the specifics of the technology, the kind of things that we do, ASCDM will edit just about any 3D file out there, dumb solids that come from a wide variety of places. You can also create 3D models from scratch, a simplified representation of something, and there's a direct link to Workbench, which I'll show very early on. So it really is the best tool for CAE tasks. We'll do things like repair dirty geometry that comes in, simplification of rounds and getting rid of features to eliminate the degrees of freedom or reduce the mesh size in a given model. And it works very well whether you're in CFD, FEA, or heat transfer related applications. And these pictures on the screen just show you some of the tools that I'll walk through today. So that's it for slides. I just wanted to set the stage with that and jump right into the software. Now, this was a model that was given to me. It's actually a step file. Now, before I jump into this, let me show you the different file types that Space Claim will open up. I'm highlighting them on the screen right now. Basically, if it's a 3D file, if it came from a 3D system, and even then some, you can import that into Space Claim, into SCDM, and manipulate the geometry, optimize it, create parameters, send it over to Workbench, all those things. All right, let me give you a flavor of that now. The whole premise of the ease of use and simplicity of the software was built around the 4 major tools I'm highlighting at the top: pull, move, fill, and combine. So we think you can accomplish by far the majority of your modeling tasks by using those. And I'll walk you through those to one extent or another in this demonstration. Now, this model I opened up, like I said, was a step file. So I don't know where it came from. I don't know who created it, but I know I've got things I might need to do to simplify it. With a tool like Move, it's very easy to take geometry and say, I want to move certain features, certain faces to one location or another. If I want to get rid of things, the tool right next to it called Fill deletes that. Now, the name may sound a little counterintuitive on those 2 features I have selected, but think about a hole. If you want to fill in a hole, this is where you use that tool. It works extremely well on things like rounds for simplifying a model. So I could double-click, intelligently gather a chain of rounds, or chains of rounds, plural, and fill those in and wipe those out in seconds. So SpaceClaim does a remarkable job at simplifying things. And you can seamlessly go in and out of tools, too. You can see I'm still in that Move tool, but I'm invoking that Fill tool to get rid of things. So very easy to do. And I'm going to keep saying it as I go along, so I want you to understand that you'll see it, just how easy this is to walk through. If I flip around to the back side, there's a lot of these pegs coming through. Now, you've seen how I can use that Fill tool, select things and get rid of them, but I really don't want to do this on the 100 or so pegs on the back side. Well, this tool is all about selection and intelligently selecting things. There's a method of selecting called power select. It looks for similar geometry in the model, namely, in this case, looking for similar size rounds. And so I've selected 108 rounds using this tool. It's strictly a selection tool. Now I can fill all those in and wipe them out. Same thing with the rounds down at the bottom of all these pegs. Use that power select tool and grab all the rounds that are the same size. Now, it did grab a couple extra ones, and maybe I want those, maybe I don't. If I don't want them, you can see just above all those pegs, I could deselect them by double-clicking. And the same thing in the other locations. But, I'll just go ahead and keep those, meaning I'll keep them selected and get rid of them. Again, that Fill tool will take, in this case, 130 rounds and wipe them all out. Now let's keep going. Let's keep getting rid of all these cones. I could keep going with that power select, and instead of selecting a round of the same size that wouldn't be appropriate here or make sense, I could use it to select all the faces that have the same surface area. And it's going to get just about everything. So a powerful search technique, I say sometimes it's like Google search within, or pick your favorite search engine, within SpaceClaim. Now it left me with a couple of sharp cones. Hey, that's easy. A box select technique and a fill operation gets rid of that. So I've quickly simplified the inside of that model. Let's do the same thing on this protrusion sticking on the outside. I may like to go ahead and get rid of those rounds that were at one time selected, and then this small little bump, fill that in. Because maybe what I end up testing this out, I find out I may need to put a rib in here to add some additional support. And maybe you just want to play the what-if scenario and see what happens if you add some kind of geometry somewhere, and see if it enables you to get to the results you're looking for. Well, it's so easy to do in SCDM. I just have to start off with a line if I want to keep things very simple and pull that into a surface, and the surface extends into a solid body. And that actually is a section or a chunk, a member of the main body. And you see me using this pull tool. This is your primary creation, editing, disfiguring, disforming tool right here. If the pull tool creates, it's that fill tool that gets rid of. So I added a rib, nothing more than that. I could easily change the size of this and say I want it to be, I want to dictate the width of it. It's 74 thousandths now. Maybe you want it to be 50 thousandths. So precision is very easy to achieve anywhere in SCDM. Maybe you want a second rib and you want to control the width of both of these. Well, you've seen me use that Move tool briefly, but if I invoke a Windows shortcut, like holding down Control, it's so easy to make a copy of this and have a duplicate right next to it. Now, these two are not related to each other. Again, this is a dumb solid, so two completely separate faces, two completely separate ribs, but I for sure can tie those together if I want to and say, well, I want the width right now to be 50 thousandths. Let's change it to 60 so you can see them both changing. But I want to add a parameter now, because in a moment I'm going to send this model over to Workbench and try to optimize it. Or I won't optimize it, but I'll just show you the integration between the two. Say you want to change the size of this hole and optimize that for whatever reason. Well, the problem is I look over on the left-hand side and see, well, that's not really a pure hole. It's actually just a cone, but it has a very, very slight taper to it. So instead of treating this as a cone, what I might do is say, let's just turn it into a cylinder. Let's just wipe that out. I use the Fill tool in a very slick way to recreate a new surface. But I want to get rid of that cone, so I fill it in. I use that surface I just made, and it recreates that. It recreates what I had forming. Turns that into a pure cylinder. A pure cylinder is much easier to define. The radius is 136. So let's go ahead and turn that into a parameter as well. What I'm doing to create parameters is using this Groups tab. And there's a lot of different types of groups you can create. You see I've got driving dimensions, fillet groups, all those fillets that I removed earlier, those get stored if I wanted to bring them back. But also name selections if you want to group faces together and send those over to Workbench and use those to define your boundary conditions. Sure, absolutely, you could do that. We'll go ahead and save this document out. Maybe I'll just throw it on my desktop and call it block. I think I already have one there, but we'll go ahead and resave that over. Okay, under this Prepare tab, there is an Ansys 14.0 button. So there's your link directly to Workbench. Now I've saved some time and I've already opened up Workbench, and this is exactly what it would look like after clicking that button. I'll go ahead and make sure that my block is the geometry that we're working with right now, and we'll keep things simple and say we want to do a static structural study, and then open this model up in Mechanical. So a little about this integration. Like I said, SpaceClaim helped drive this with Ansys. It's a bidirectional integration, very quick in what it does. So you see the model that I brought over from SpaceClaim. We'll go ahead and take those properties that I created, namely the width of the ribs and the diameter of that hole, and we'll turn those on. So those are now enabled. Going back to Workbench, you see the two properties there. Well, let's make a drastic change so you can see the difference and see how the integration does work. The width, and by the way, you can change the parameter names anytime very easily. We'll call it 20 thousandths instead of 60. And the diameter of the hole, 50 thousandths. So drastic change. Go ahead and update the project. You'll see the model update right here in Workbench. The ribs are significantly thinner and the hole smaller. Same thing is true if I go back into SCDM. There's your hole. There's this different size of your ribs. I could have made the changes right here in SCDM too, and it would have sent its way back over to Workbench. So that's the bidirectional nature of the integration. Very slick. So hopefully you can see how you can spend some time in SCDM to optimize your model, and go back and forth between Workbench and SpaceClaim to get exactly what you're looking for. And you guys know Workbench probably much better than I do in Mechanical. From here, go in and mesh this model, see what it looks like. If it's not ideal, go back to SCDM, start making some changes. Okay? So I want to transition now to another model that was kind of setting the stage and talking about removal of rounds. We'll go ahead and open up another step file, and this will transition a little bit into the repairing of bad geometry upon importing into SCDM, and also extracting out things like a volume. Now, from my understanding, a lot of you do FEA and a little bit of CFD work, so this will touch a little more on the CFD side of things, but there's definitely some carryover between the two. I open this model up, and you can see the exhaust manifold, how it looks a little bit transparent with different colors, and it doesn't come through as a nice opaque solid color. Well, let's open that up, and we'll see what's going on. So it's easy to open up models separately. You'll see there's 244 surface bodies in the model. Well, that's a dead giveaway to me that I need to use my repair tools, and namely ones that will attempt to solidify this model. Now, these are all automated tools. SCDM will walk you through the process of what to do in attempting to stitch bodies together, stitch surfaces together. If you have a watertight collection of surfaces, it'll form a solid right there. Now, this one didn't because there's probably some other issues, namely like gaps, where there's small openings where two lines exist and there should be one. So I zoom in on that gap. Now what we do, again, with an automated tool is do an approximation and join those edges together. I still don't have a solid. So I know there's some missing faces more than likely. Yeah, and SCDM tells me there's 4 areas where it found missing faces. And the best way to remedy those is to take a patch and stick it right over those. When I click that green checkbox, it actually heals all of them up at once. Now I've got a solid body to work with. And this is a legitimate solid, meaning you could mesh it. You can even make changes to it just by pulling on faces. Now maybe for the purposes of your mesh, you want to divide up this solid into a couple different pieces. Maybe along this face, you want to split it up. Well, it's 2 button clicks. Well, 1, I had to grab the face, and 2, I invoked that tool called Split Body, which breaks this up into separate bodies. So for sure, you're going to have some kind of a boundary condition where you need to identify the points along this face where the other body imprints on it. Well, there's a tool that does that. I click a button, Imprint. SCDM will look through the model and find wherever there's an edge-to-face contact and identify all those locations, however many there are. And again, the great thing about these automated tools, you click a green checkbox, and then we'll go ahead and make the imprint from one set of edges to the face as appropriate. Okay. So that just worked its way through. We'll go ahead and look at the imprint. There you can see it clearly. A couple other things you might want to do. One other thing you might want to do on this model to simplify the mesh is merge some faces together. Now there's quite a few that you could do in this, but I'll just pick on one, maybe up here. These faces, it probably doesn't make sense to have them separate. So one way you can handle that is to use a Merge Faces tool in SpaceClaim. Grab the things that you want to merge. We'll do an approximation and find out if there's any tangents, see if there's not. It makes minor adjustments at a small level and creates the tangency and merges the faces together. So you could go through the model and find all those, merge anything and everything that you want together. With small faces too, I don't think there are any in this model, but it will find tiny faces that fall under a threshold or over a threshold and wipe those out for you. It'll essentially merge them with faces nearby in the model. So these two tools are very much related to each other, but that's how they work. Now let me go back to the main model. There's actually a lot of things I could do, and I typically do in this, but I want to shorten it up for the purposes of just this demonstration. I want to create a solid volume that represents the inside, wherever air and wherever gases can flow. It could be a very complicated thing to do in your typical CAD system. It's really not difficult to do in SpaceClaim. I'll hide a couple components that I don't want or I don't need. But in order to create this solid body that represents the inside, I really need to make sure that there's no openings in the model. Now there is a somewhat fast way to find those. I'm going to skip over that because I know ahead of time where they are. It's really as simple as just trying to merge bodies together. And if they don't merge, well, you know there's probably some kind of an opening between them. So what I've done is open this up, and I've cut it in half. I've gone into a cross-section mode. The great thing about looking at things in a cross-section mode in SCDM is that it's not just good for visualization anywhere you want, but you have full editing capabilities too. So this catalytic reduction chamber, I take the very end of that, pull on it, and create a definite interference between itself and the green body. And I'm done right there. Now, again, I know ahead of time there's another opening on this body. Let's go ahead and find it. I think it is right over here. Again, I'll go into, select an axis and go into a cross-section mode. And I'll draw on the screen for a moment. You can clearly see where, gases could escape out. So let's take care of that. Instead of pulling one body into another, I may elect to make a brand new surface. So again, even in this cross-section mode, I can start creating geometry. I'm making a new surface, a ring, namely. Pulling on that will make the definite interference between the two bodies and merge them together. And you're probably not concerned with the tiny geometry around the edges like that, and that could very well be adequate. And the reason that there's some openings here is maybe a translation didn't come through correctly, or maybe the engineer that gave you this model neglected to put certain components in there for whatever reason. But you have the power to go correct these minor problems, which could be major problems, in SpaceClaim. All right, now it's time to create that volume. Again, this could be very difficult to do and a lot of steps in any other pre-processing 3D system. But we've got it down to just a couple of button clicks in SpaceClaim. And the idea is that I want to cap off, I want to designate in SpaceClaim what all the openings are. Well, there's one opening on the end. and one at the manifold. All I have to do is tell SpaceClaim an inside surface from where to start. I've capped off the openings. I tell it an inside surface, and I click a green checkbox, and that's it. So essentially, 4 button clicks, and I have the internal volume. Now let me hide everything else except for this volume. That's everywhere that gases could go. Now here's where the fun is. This is where your optimization really begins. Obviously, you could send this model over to Workbench, mesh it, do whatever you need to do, come back to SpaceClaim, and really start to modify this. Maybe you care about the angle of this catalytic reduction chamber. Sure, go ahead and modify it. I'm not even modifying the real geometry. I'm modifying the volume extraction. So you can see how this is true simulation-driven design. Optimize your design through the results. And this is really unprecedented because, unfortunately, the simulation of a lot of models tends to fall way down the line, and it doesn't have time to work its way back into designs. Now you can really do that in an unprecedented way with SpaceClaim. All right, let's transition to another model. This is going to be the last one I want to show, and then we'll turn things over to questions. I'm going to go over it and talk about some beams and shell elements because I understand this is very important for FEA. Here's another simple step file. By the way, it's so easy just to drag and drop things right into SpaceClaim, and it quickly opens them up. Really easy to do. So this model has a lot of thin body elements, and there's a lot of things we need to do to optimize this. From a designer's perspective, this may be complete, but from analysis perspective, no way, not at all. There's a lot of things you have to do. And we'll get it down to just a couple of button clicks in SpaceClaim. There's a mid-surface tool dedicated for taking thin body parts, thin wall parts, and extracting out the mid-surface. We'll find the offset pair, click a green checkbox, again, that automated tool, and we'll hide the main body and show you just the mid-surface. Now that's just one mid-surface. Do I want to go through this whole model and do that on every thin body part? Absolutely not. That's kind of a waste of time and a poor use of tools, so we have really streamlined it and allow you to search. Well, I'll give it a couple search, a range, maybe a ½ an inch up to 2 inches. And I'll go through and do a big box select and tell the system essentially find all the faces that you can mid-surface. And it found quite a few there. Click the green checkbox, and we extract out the mid-surface of all those. That's very fast. Now there's a bunch of them that I missed. That's okay. I run through another operation and do the rest of them with a simple box select. And I have them all done. Now that's just the mid-surfaces. They all show up in a nice, clean component in your structure tree so that you can organize them, turn them on or off, do whatever you want with them. You know, I really don't want to look at all those mid-surfaces in my tree individually. It kind of gets a little messy. So I might say, let's just right-click and move these to a new component. It's so easy just to drag and drop things or group things differently in SpaceClaim however you want. So you could always rename this, call it mid-surfaces plural. And I want to hide all those for a moment because I'm done with them. Let's just get rid of them. What I have left on the screen is everything I need to extract out as a 1D beam element. Well, we have a tool for that too, extract. A similar workflow, same kind of thing. Grab everything that's a beam element, and we'll turn it into a beam right away. Now, what we do to simplify things is show you just the wireframe, but you can always go back and show sort of a silhouette of what that cross-section actually is. And what we've done in the structure tree is show you all the extracted beams. Now, if you want to go through and look at the cross-section of any of these, sure, you can do that very easily and even modify it. So if I modify the cross-section in any way, it will go through. The cross-sectional properties will get transferred to Workbench as well so that you can properly run an analysis that you want. Now, like I said, the design engineer may think that everything included in this model looks good from their perspective, from the manufacturing perspective, but certainly not from your perspective. There's a lot of nodes, a lot of edges that do not touch each other, and a lot of faces that don't have contact with edges either. Now you've seen, or hopefully you've seen some ways that I could do that. I I could take an edge, for example, and start pulling on it and have it snap up to a certain location if I want to. That's a way to do it, but I would say that's probably the very slow way to do it. Now, before I go in and start taking care of edges and node points, I may say, let's take that mid-surface, there's a couple of them in the middle, and get rid of all those edges where the cross-sectional members go through. It's as simple as taking edges and filling them in. I mean, that is just lightning fast what SCDM does. It's simplifying all those edges and just extending out the natural progression of that face. All right. So how do you correct all the edges? And you guys probably know what I mean, but I'll just zoom in and show you exactly what I'm talking about. The mid-surfaces obviously don't touch. You don't get an edged face connection. Well, within this Prepare tab, there is an Extend tool. I click on Extend, and there's a number of options to change. One, namely, would be changing the maximum distance for which I want to search everything. So let's just crank it up to 4 inches. You see all the node points of those beam elements and how they extend a little bit too far. If I zoom in on one of them and click that red area, you'll see it kick back over to the right, and now it's coincident with the face of that large cylinder. Similarly, there's certain edges that need to extend upwards a little bit or downwards, depending on your perspective. I'll zoom in on one. I click it. That automatically extends up to that face. Now, I don't have to go through these individually, but again, a green checkbox will run through them all and take care of the problem for me. The only issue is that some faces don't need to extend. They need to be trimmed back. So there's a tool, there's an option to invoke that lets me do that. Now, it found a little bit too many because my maximum distance was set too high. So if I drop that back to, say, 1 inch, I think it finds more the appropriate amount. There's a couple other options in here to control as well. I'm not going to go through all these with you, but the point is you can get things done very quickly, very easily here in the software. Take, for example, when I click that partial intersection button. It finds that little L-shaped cutout. Maybe you want that, maybe you don't. But for simplification purposes, it might be easier just to get rid of it. So we find all those little problems and let you extend out elements just like that. And again, this model would be complete. You could send this over into Workbench, run your analysis as needed on it. One more thing to show. This beam element doesn't actually intersect the outer cylinder, that mid-surface. Maybe you want the beam element to actually touch it, but you don't actually want to move the location of that cross-section of where the structural member actually is. Well, that's easy to do. Going into a cross-section mode might be an appropriate or a good way to view this and looking straight down at it. I could just tell SpaceClaim to go ahead and keep the beam fixed but move the element whatever direction I want. And let's go ahead and snap it. I can always add precision. Remember that I can snap it up to the very end of, or the cylinder, the diameter, and do the same thing with the one on the right-hand side. So we'll go back into 3D mode. You see how easy that is to do. The element, the 1D element is on the OD, but the cross-section is where it remains. One more thing I wanted to show that I forgot about. I want to turn on an option called Shared Topology, and this is part of the integration between SCDM and Workbench. What this does is if I want to see where all the edge-to-face connections and edge-to-edge connections are, I can click a button called Show Contact. So everything in blue is where I do have a connection point. Everything in red is a solo edge or point. There's a couple of faces, namely 4 of them, that do not actually touch other edges. And so I might need to modify those or move them around. And that's the key right there, is that I might want to move them. These 2 faces, I can move them up and down, but I actually want to snap them to the corresponding face in the middle. And same thing with the mirror pairs, at the very top. I don't have to move them as I did right there, but I'm just doing that for effect. snapping them up to those faces. Now when I run that show contact option, hopefully you can see the edges along the bulk of the perimeter, the 3 edges of each of those faces is now blue. And you have the solo edge sitting out front. So this can really give you a great visual indication of if you have all your contact points and your nodes lined up properly. All right, so that's all I had to show you guys. So we've kept this right around half an hour. That was my goal. And I'm sure some of you have questions. We'll go ahead and turn it over to you guys now. And we'll take a look at, see if there's any questions coming through in the chat box. Christina, if you want to jump on and say any closing remarks. If you guys have further questions about SCDM, definitely contact the folks at CAE Associates, and they will get you information on the software and involve us as needed. And we'll be happy to give you an extended demonstration or show you more capabilities of what the software can do.
Great. Thanks so much for everything, John. We really appreciate everyone's attendance today, and that's all we have. Thanks so much.